Okay, so for this part of the algebra, we are going to learn some definition. We are going to learn how do you add and subtract algebra. Okay, so one of the basic algebra definition. Okay, so this one is one of the basic one. So when we talk about an algebra term, okay, it consists of a coefficient and it consists of a variable. So a coefficient is just like the number beside the algebra. Okay, so for example, if you look at this one, 4a. So if you look at this, 4a. So it's an algebra term. So the coefficient will be 4, and then the variable will be a. So coefficient is just the number, variable is just the algebra. So in this one, minus 5 and x squared. So minus 5x squared. So the coefficient part will be the number, minus 5. The variable will be x squared. Okay, in this, the other term here, 4/5 xy. 4/5 will be the coefficient. Xy will be the variable. So it contains two, in a way, two algebra, but we consider them under variable. Okay, 7b cubed. Okay, 7 is the coefficient. The variable is b cubed. Okay, so from here, right, we will actually, if we need to explain a little bit, that means for 4 is the coefficient of a. Minus 5 is the coefficient of x squared. Okay, 4/5 is the coefficient of xy. 7 will be the coefficient of b cubed. So that's how we describe. Okay, when you see a number like this, there is no algebra. So when there is no algebra, right, essentially it is called a constant term. So here, 5 is a constant. So a number that doesn't come with algebra is known as a constant. Okay, then we will need to be counting the number of terms in an expression. So for example, here, this one. This term is 3a. Okay, and this one is a constant term. So how many terms are there in this expression? So this expression contains 2 terms. Then this part is an algebra term. There's a number, there's an algebra. Okay, this one is also a number and an algebra. In this case, the number is 1x. But we don't usually write 1x. We just usually write 1. We just write x. And then here, this is the constant term. So here this expression has 3 terms. Okay, then here, okay, this one consists of a number and variable, 1 term. A number and a variable, 1 term. Here also consists of a number and variable, 1 term. There is a constant which also consider a term. So in this expression, it contains 4 terms. Okay, so if you got used to the number of terms and like the coefficient, the next thing is you need to know what is called like terms. You need to know what is called unlike terms. Like terms, if I go for the definition, it must be the same variable with same power. But the coefficient can be different. the coefficient can be different. So let me give you an example of like terms first. So like terms will be like x minus 2x, like 1/3 x. So you look at the variable. The variable is x. Okay, but they have different coefficient. So if you look at the coefficient, this is 1x. This is coefficient of 1. This one is coefficient of -2. This one is coefficient of 1/3. But they are considered like terms because they got the same variable and same power. So what do you mean same power? Okay, what if I give you a different power? So for example, if I give you like x squared and -2x. Okay, if you look at the powers, okay, this is a x squared, the power is 2. This is a x, power is 1. So they are considered unlike terms. So think about unlike terms as a different family. You can think about different surname. So the variable is like the different surname. Okay, so why is it important to identify like terms and unlike terms? Because when we add algebra, we can only add the like terms. So in this case, right, I can add x plus -2x plus 1/3 x. I can add them up. And how I add them up? I can punch calculator. I can punch calculator with the coefficient 1 plus -2 plus 1/3. So when I punch calculator, I get -2/3. So when I add them up, right, I will get -2/3 x. So we can only add like terms. So like this example, when they are not like terms. So example, if you need to add them up, that's all. I cannot add them up already. So I can't go on any further. I cannot be adding them. I cannot punch calculator like this because they are unlike terms. So it's very important that you can identify like terms so that you can add correctly. Okay, so further example of like terms. So if I got the x squared, 6x squared, 9x squared minus 2x squared. So everything is dealing with x squared. It is the same variable, same power. So they are considered like terms. So we can actually add all this up. But if I gave you something like 3x squared and 6x, they look like they are x also, but they got different power. So cannot. So, or maybe I can give you an x cube. Then they are also not the same family. Okay, some more example. So maybe what if it's not just x and x squared? So what if it's like 7xy, half xy, and minus 4xy. So it is the same variable xy. Same variable xy, so they are the like terms. So if I give you a 7xy versus minus 10xyz, they are not the same. Because this one is a xy. This one is xyz, got an extra alphabet there. So they are considered different families. Okay, so be careful. Okay, let me give you a bit more complex one. So what happened when I gave you like 9x squared y and like 17x squared y? So can you see it's exactly the same algebra and it's the same power. X squared is x squared, y is y. So they are considered same family. But if I gave you like this, they are not the same because x squared y, x is x squared. But if you look at the x here, it's just the x. So even though it's same algebra, but the power is not the same. Same thing, this is y power 1, and that one is y squared. So both are different families. So we need to be exactly the same. And even the constant are considered like terms. So maybe I give you a -1. This is a constant. 7 is a constant. -20 is a constant. So that is also considered like terms because all are constant. It doesn't come with algebra. But if I give you a -1 and algebra A, then they are different because this is a constant. It doesn't even have an algebra. And this one consists of a variable. There's a variable with this algebra. So what is so important about this? We can only add or subtract like terms. So think of like terms as same surname. So they are in the same family. So the surname is characterized by the algebra. And the algebra must have the same power. It's not just x and x. X and x are the same, but x and x squared are not the same. So that is the main confusion sometimes. Okay, so with this, right, I'm going to show you a very simple example. How are we going to add? So for a start, I would suggest that you bubble up the term. So when I bubble up x, right, it means it's 1x. Okay, this one is a 7y. Remember, a coefficient plus a variable becomes a term. A coefficient plus a variable becomes a term. So you circle up one term. So one circle is like one term. So I'm going to circle the term. So there are 4 terms here. Right. So just now we learned about like counting the number of terms. So this one got 4 terms. We are going to reshuffle the 4 bubble. Okay, it's just like your stationery, you just reshuffle them. So I'm going to reshuffle in such a way that the X bubble will come together. The Y bubble will also come together. So you reshuffle the 4 bubble. Okay, why is it important to reshuffle? If you got 4 terms, after you reshuffle, you still must have 4 terms. You cannot like have an extra term after you reshuffle, or you got 1 less term after you reshuffle. So reshuffle is only changing the position. Okay, so what is the purpose of the changing position? So that the like terms can be simplified. So 1x minus 3x. So you can punch calculator 1 minus 3. So you get you a minus 2x. Then this one, minus 7 minus 4. So 7y minus 4y. So that is another family. So this one, you can punch calculator 7 minus 4, you get a positive 3. So you get a positive 3y. So that is how we reshuffle and then we simplify them. Simplify means we just add or subtract according to what we see. Okay. Gradually you will find that you may not need to reshuffle. That the moment you see them, you can simplify them. That's also fine. Okay. But for a start, I don't want you to make careless mistakes. So reshuffle them first. Reshuffle the same family together. So in the next question, we got a constant. So this is a term as well. We got a xy. We got a constant and we got the xy. So I'm going to reshuffle the constant together. I'm going to reshuffle the xy together. Okay, so this part will have given me a very nice number, 4. Then for this part, 4xy minus xy. So there is a 1 here. There's an invisible coefficient. So you can punch calculator 4 minus 1, or you think of it as 4 minus 1. So you get plus 3x1. Okay, so if let's say another student gave me an answer like 3xy plus 4, that is perfectly correct also. So it's okay to reshuffle. So the same thing here. If let's say a student gave me 3y minus 2x, that's also correct. So if I write 3y first, I do not need to write the positive. It is unspoken that when you write 3y is positive 3y. So it's okay to shuffle. It doesn't mean that the certain thing must come first. Okay. So in the next one, we got the algebra A, the family of A, family of B, family of A, and family of B. So put the family together. A family together, B family together. So when you see the A family, half A minus 2/5 A. Okay, you can think about punching calculator, half minus 2/5. You can think about punching calculator, half minus 2/5. It will give you a 1/10. So this, the A family will be a 1/10A. For the B family, so look at the B family is plus B minus 1/3 B. So the plus B is actually 1B. When we say plus B, it's actually 1B. So you can punch calculator, can think of it this way. 1 minus 1/3, then that will become 2/3. So the B family will become positive 2/3 B. So when you punch calculator, you get 2/3. That is a positive. If it's negative, it will be shown on the calculator that it's a negative 2/3 already. So that's how we reshuffle the like terms, and then we simplify the like terms. Okay, so you must look for the like terms. If you don't add the like terms, of course, you will get it wrong. Okay, so of course, sometimes we also make careless mistake. Okay, this one is very simple. So make sure it's like 100% accuracy.